Saturn V. This massive three-stage rocket was developed by NASA specifically for the Apollo program in the 1960s and remains the only vehicle to have carried humans beyond low Earth orbit. Standing over 360 feet tall, it generated a staggering 7.5 million pounds of thrust at launch to break free from Earth's gravity with the Apollo spacecraft. Its engineering relied on a combination of liquid oxygen, kerosene, and liquid hydrogen to achieve the incredible speeds necessary to reach the lunar neighborhood. By successfully launching 9 crewed missions to the moon, it proved that human lunar travel was possible and established the foundational physics and engineering standards for deep space exploration. Space Launch System. Developed by NASA as the modern backbone of the Artemis campaign, this heavy-lift rocket represents a bridge between space shuttle technology and the future of deep space exploration. It utilizes core stage engines and solid rocket boosters derived from the shuttle program, but configured in a much more powerful arrangement to push the Orion spacecraft toward the moon. Unlike its 1960s predecessor, it relies heavily on updated flight software and manufacturing techniques like friction stir welding to improve reliability and structural integrity. This vehicle matters because it provides the initial uncrewed and crewed heavy lift capability needed to establish a sustained human presence on the lunar surface during the early Artemis missions. Starship. Designed and built by SpaceX, this fully reusable transportation system represents a massive shift toward commercial partnerships in modern lunar exploration. The system consists of a massive super heavy booster and the Starship spacecraft itself, both powered by engines that burn liquid methane and liquid oxygen. NASA selected a modified version of this spacecraft to serve as the human landing system for the Artemis 3 and 4 missions, where it will dock with Orion in lunar orbit and carry astronauts down to the surface. Its ultimate significance lies in its massive payload capacity and full reusability, which aims to drastically lower the financial barriers of transporting heavy equipment and infrastructure to the moon. Falcon Heavy. Another vehicle from SpaceX. This operational heavy lift rocket provides crucial support for the logistics and infrastructure side of the new lunar rush. It consists of 3 structural cores bound together, essentially combining 3 Falcon 9 rockets to tripling the thrust available at liftoff. While it is not designed to carry astronauts to the moon, NASA has tapped this rocket to launch the first foundational pieces of the Gateway Station, a small outpost that will orbit the moon. Its ability to land and reuse its booster stages makes it a highly cost-effective option for sending cargo, scientific instruments, and habitat modules into deep space ahead of human arrivals. New Glenn. Developed by Blue Origin, this heavy-lift orbital launch vehicle expands the competitive landscape of the aerospace industry and adds redundancy to lunar logistics. Named after astronaut John Glenn, the rocket features a reusable first stage designed for at least 20 flights and is powered by liquefied natural gas and liquid oxygen. A modified derivative of its upper stage architecture is integrated into the Blue Moon human landing system, which NASA selected as a secondary transport option for later Artemis missions. By introducing a completely independent launch architecture, it ensures that lunar exploration can continue smoothly, even if other rocket systems encounter technical delays.